Dear students, Namaste. I'm going to teach you business mathematics of grade 12. I want to start second chapter, set and relation. I first of all, I want to give you some concept, some review of your previous classes. So I want to give you some uh, definition and ideas. Now I want to share these ideas. Now it is a chapter set, so I want to first establish the definition of this set. Are well-defined objects, or you can say those objects which can be defined easily, or you can define those objects, then the collection of those objects are the set. So a well-defined collection of objects is your set. So for this set you must have your defined well-defined objects. For example, if you take natural numbers less than 6, that is 1 2 3 4 5, these are your well-defined collections. Similarly, even number less than 10, that is e is equal to 2 4 6 8, these are also well-defined objects. But not well-defined, what is your non-well-defined? That means tall boys of your classroom. What is the uh, define or definition of this? Your tall boys in your classroom, this is not exactly definition, so you can take any one height is your tall, so it is not a well-defined objects. And good looking people, it is not also a well-defined object. Similarly, if you take the drops of water from river, it is not well defined. So for set you must have well defined. So your definition is the a well defined collection of objects is set. Okay. Then after we are going to represent this set in three ways: listing or tabulation method, descriptive method, rule method, or set builder method. Now for first listing or tabulation method, you know it is A is equal to 2 4 6 8 10. It is only directly writing those elements, and description is in your language. For example, A is equal to first five even numbers, then you can understand this one. And last one is it is set builder or a rule method. You can write down this is A is equal to set of x, or that x is an even number, x is less than 11. So in this form, in the form of this one is a set builder form. In this language is your description, and you can write down directly element, it is your description method. Okay, I want to give you some types of set. It is finite set. You must have a finite number of elements. So A is equal to 1 2 3 4 5. These are finite number of elements, so it is your finite set. Infinite set, you must have infinite number of elements, it is your infinite set. For example, if you take the natural number 1 2 3 4 5 dot, 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 these are your infinite set. For here b is equal to set of x is a natural number. Then another definition, null set or empty set, you must have nothing there, it is your empty set. That is c is equal to set of x is a natural number less than 1. You don't have any number which is less than 1 in natural number, so it is your null set. Singleton set, a set which is only one element, is called your singleton set. In your example, c is equal to only p element, it is your singleton set. Similarly, d is equal to the highest peak in the world. Which one is the highest peak? Mount Everest is the highest peak, so there is only one peak in the world, so this is your singleton set. Similarly, I went to the relation between set, subset, proper subset, disjoint set, equal set, and universal set. These are basic concepts, so I want to skip these terms. Subset, these I want to skip these. Then I want to give you the concept of Venn diagram. uh, if you have a u is equal to 1 2 3 4 5 6 7 8 and 9, then a is equal to 2 4 6 8, b is equal to 2 3 5 7, you can represent these in your Venn diagram. How can you represent this one? So these are subset of universal set. Now which one is common there? 2 is common there. Now write down in their intersection part, and how many elements left in set A? 2 4 6 are left here. 2 6 8 you should write down inside A. Similarly, how many elements? 3 5 7 are missing there, so write down there in B. And out of these these elements are, yeah, containing these two circles, but 1 and 9 are missing, so write down 1 and 9 in outside these two circles. So you can plot your set and subset, your universal set, in your Venn diagram. It is a simple idea for you. Okay, operation on sets. So I want to give you some concept on union of set, intersection of sets, difference between two sets, and complement of a set. First of all, union of sets. So you can take two sets A and B. So what is the union of these two sets A and B? You should take all elements but don't do repeat. You should take all elements but don't do repeat. That means A union B is equal to write down all elements from A and B but don't do repeat. That means two, there are two terms, so write down as single, then 3, 4, 5, 6, 7, 8. Write down all. Then you can plot in your Venn diagram. Similarly, for intersection, which is your common element, 2 is your common element in both sets, so A intersection B is equal to 2. Similarly, difference of this is those elements from A not from B. That means A minus B is defined as difference between A and B. So those elements from A, that is 6, 4, 6, 8 from A, not from B. Now these are these elements are A minus B. Similarly, B minus A is those elements from B, not from A. 3, 5, 7 are A minus B. Then after complement of a set A, difference notation of this one, you can denote it is A bar, A dash, A C, and you can take it is complement is you have a subset of A universal set U, then A complement is equal to U minus A, and B complement is equal to U minus B, then you know all these also. Similarly, I want to give the concept of this cardinal number. So you can take it is universal set rectangle, inside rectangle it is universal set U, then you can write down it is NF U. You have two sets P and Q. So the common of both set is E. This is, you can say it is your intersection. So NF intersection Q it is. And this whole is NF, but if you take this only this portion, it is only of P and not of P. There are four elements, so it is n not of P is equal to 4. Similarly, this portion is n not of Q, so it is your 3. Then collection of all these two circle is union, and outside of these two circle is your complement. You know all these. Then after for this one, I want to give you, for this one I want to start your exercises too fast. For this, I want to show you uh, exercise 2 first. It is your question number 1. Now it is, if A is equal to A, B, C, D, X, Y, Z, A is equal to A, B, C, D, and B is equal to X, Y, Z, and C is equal to A, C, X, Y, find the followings. Then A union B, you can find out B union C, A complement B minus C, A complement intersection with B complement, B complement union C complement. Now solution of first. So you should find out A union B. You should take A and B like this way, A and B, and write down all elements but don't do repeat. So A, B, C, D, X, Y, Z. It is simple. Then after I want to do question number B. For this B, A complement intersection B complement. First find out A complement. A complement is U minus A. U is A, B, C, D, X, Y, Z. And A is equal to A, B, C, D. Then how much? Write down elements from U, not from A. That means A, B, C, D are A. So left these A, B, C, D, and how many remain there? X, Y, Z. So X, Y, Z is A complement. Similarly, B complement is U minus B. U is A, B, C, D, X, Y, Z minus X, Y, Z. Subtract X, Y, Z. You got A, B, C, D. Then after we need to find out intersection of these two. A complement intersection B complement is equal to X, Y, Z intersection with A, B, C, D, but there is no common element, so it is your empty set. Like this way, you can do all your questions. I think you can do all these questions. Now I want to give you question number 3. This is also exactly same as U is equal to A, B, C, D, E, F. A is equal to A, B, C, E. B is equal to A, C, E, G. C is equal to B, E, F, G. Verify that A union B intersection C is equal to A union B intersection A union C. First find out first find out B intersection C, then after A union B, then after A union C for first question. Similarly for second, like this way, which term is in bracket, first find out that one, then you can verify this. So solution of first is First find out A B intersection C. B intersection E is write down element of B and C. B is A C E Z. C is B E F G. Then your intersection is E and F. Similarly, A union B is equal to A B C E union with A C E G, and find out this is A B C E F. Then you have it is B intersection C. A union B, again find out A union C. So you have here A union C. Now A is A B C E and C is equal to B C E B C F G. Then find out union, it is A B C E F G. Then for this first part, A union with B intersection C. A union with B intersection C, write down the element of A, then write down the element of B intersection C, this one E and G. Then union with this is A B C E G. Similarly, A union B intersection A union C. Then write down the value of A union B and intersection with union of A and C. Then you got A B C E G. A B C E G and A B C E G, these both results are equal, then you can say it is verified. Like this way you can do second number, third number, fourth number, all these. Okay. Then after, I want to give you question number 5. For this one, your question is first, if n of u is equal to 100, n of a is equal to 75, n of b is equal to 40, n of a union b is equal to 80, n of a intersection b is 80. We need to find out n of a intersection b, n of a minus b, n of b minus a, and complement of a union b. Also find, if b is subset of a, find n of a union b and n of a intersection b. For this one, we have formula n of a union b is equal to n of a plus n of b minus n of a intersection b. Write down the value of n of a union b, it is 80, n of a is equal to 75, n of b is equal to 40, n of a intersection b we need to find out. Then write down this in another side, and it is 115 minus 18 is 35. So you got the value of n of a intersection b. Similarly, you know n of a minus b is equal to n of a minus n of a intersection b. It is 75 minus 35, it is 40. Similarly, n of a minus b is n of b minus n of a intersection b. It is 40 minus 35, it is also 5. Then it is your complement, n of a union b complement, n of u minus n of a union b. Now it is 100 minus 80 is 20. It is your solution of this one. For second part, you can remember here, B is subset of A. B is subset of A. If you take the union of A and B, you got exactly this greater circle. So n of A is equal to n of A union B. So don't forget, if B is subset of A, in this case n of A union B is equal to n of A. And B is subset of A, then you can say again n of A intersection B is n of B, this portion. Okay. So here, if B is subset of A, then you can write down n of A union B is equal to n of A is equal to 75, and for this n of A intersection B is equal to n of B, and it is your 40. So it is the completion of question number 5. Second part is this one, and for 5 seconds, if A and B are disjoint, if you suppose these two sets are disjoint, no intersection part is there, so you can write down there n of A union B is equal to n of A plus n of B. Your question is n of A union B is given there, n of A also given there. We need to find out n of B. Now substitute all these value. It is 475, it is 435 plus n of B. Then find out n of B, it is your 30. It is your solution of 5 seconds. Okay, I completed question up to question number 5. Please, students, do up to question number 5. Then you can ask me if I have any question in my class. Thank you.